This is page 7 in your course book, the notes on mass. In order to measure mass, we use what is called a triple beam balance or an electronic balance. Mass is measured in grams or kilograms depending on whether you have a small amount of mass or a large amount. Or for really small things, we use milligrams. Here are some examples of items we would use these units for. So a paper clip is about 1 gram of weight. A heavy textbook would be 1 kilogram. A grain of sugar would be about the same as 1 milligram. So those examples show you the vast difference between those units. Mass is different from weight because weight depends on the pull of gravity. For example, your weight on the Earth would be more than your weight on the Moon because the Earth is larger and the pull of gravity is stronger. Your mass, however, would be the same in both places. You would still have 2 arms, 2 legs, a head, etc. In other words, your mass would be the same because you would still be made up of the same stuff on both planets. So a reminder, mass is something that takes up space, while weight is the pull of gravity. So gravity changes on planets, so that's why our weight changes. But our mass stays the same because how much space we take up will always be the same. So even if I take my body into space, I'm not going to become super small all of a sudden. I'm still the same amount of space taken up, and that is what mass is. So below, you're going to complete a chart using the King Henry setup that we talked about in the last video, and we're going to use grams as our base unit. So here I filled in the chart. So the chart you have in your book is actually too small, so I had to go in and add 2 more rows. So sorry about that. If you want to do it on a separate sheet of paper and then tape it over this one, you're welcome to, especially if you have big handwriting like I do. And you're just going to use the chart we did in the notes before to fill this out. So King Henry died unexpectedly drinking chocolate milk Monday night. And this time our base unit is grams. So I put grams here, and that's going to follow behind the other units. So for kilo, the kg for kilograms, hectograms, decograms. So once you set your base unit, that's what you're putting behind the letter from our memory device. Here, this is a special symbol. It's not a typo. It kind of looks like this, and this means micro. So this is micro. It's not a letter. It's a Greek letter, not an English letter. So micrograms, nanograms. So I'm going to show you one example since this is our first practice. Here I have 45 milligrams. So just like the example we did in the last notes, I'm going to write out my mnemonic device. Milli is the first M, and I'm going from milli to our base unit grams. So I'm going to jump 1, 2, 3 times to get to grams, which is our base unit. So it jumps 3 times to the left. And I'm going to do the same thing here with my decimal. My decimal was here for milligrams. 1, 2, 3 to the left. And I need to put my placeholder 0. So the correct answer for this would be 0.045 grams is the same as 45 milligrams. So you see how small that is? That is like a that's 45 grains of salt, of sugar, excuse me. So it's like 1, 2, 3, 4. It's not a lot of sugar, right? It does not weigh that much. That's a super small amount. So go ahead and continue doing these practices on your own. And just so you have the last bit of the notes, on the very bottom it says, on the planet Jupiter, my weight would change and my mass would stay the same. Because we talked about how mass is space taken up versus weight is the pull of gravity. So that's the main difference between those two. So go ahead and finish those practices, and then you're going to complete the next 2 pages for your asynchronous work.